Hey there everybody, Mr. Lewis here, ready to start Unit 2 with you today. So Unit 2 is all about population and migration. The dynamics of the population, the distribution of a population, the composition of a population, and then how that population can change over time with fertility, mortality, life and death, or immigration and emigration. So it's really a study of all of those dynamics within the population and what their impacts are on the culture within a country or a state or a given region, the economy within that region, the political structure within that region, the environment in that area. So population can have a huge impact on any number of things, and it can be, in some cases, very technical, just looking at like the statistics and things of that nature, but it can also be very humanized. When we look at stories of migration, and why people are pushed away from certain areas, be it violence or persecution of some type, or why they're pulled to a certain area because of economic opportunity or the freedoms that they might enjoy in that particular country or place. It's really interesting to look at those stories. So this is one of my favorite units that we get to look at all year. Let's dive into it today with sections 1 and 2. All right, so first of all, there are 3 big ideas that we have to consider when looking at Unit 2, Population and Migration. The first big idea, or first big question, is how does where and how people live impact global cultural, political, and economic patterns? So how does population impact culture, politics, the economy? Second, how do those things, the environment, the economy, culture, politics, how do those then influence changes in the population? And finally, how can those changes in the population in turn impact the economy, culture, politics? So you probably noticed we use these as our ongoing themes for this course. We're always looking at economic change, environmental change, cultural change, the political impact, the social impact. All of those things we will always consider. And today, we're considering them in the context of population and migration. So there are 4 big changes that can occur within any population, and we need to understand these 4 statistics or 4 patterns now. 1 deals with life and death. So fertility and mortality are each a distinct statistic that we might look at to calculate natural changes in the population. Okay, naturally, people are going to be born and they're going to pass away. And so if more people are born than die in a population, there is a positive natural change in that overall population. More people are coming into the population than are leaving it. The same is true for emigration and immigration. So migration patterns are the other half of this equation. When people are coming into a country, they are considered immigrants. When people are exiting a country, they are considered emigrants with an E. So into immigration, exiting emigration. Between these 4 factors, the population can change in a couple different ways. So let's first look at the distribution of the population. Even disregarding fertility and mortality, migration, and any of that stuff, we can look at where the population is found and why the population is found there. We can also look at the consequences of that population distribution. So first of all, there are 2 main factors that might lead to one particular area being more or less populated. Physical factors are one half of this equation. The climate, landforms, bodies of water, these can all be reasons for a high population or low population within a particular area. Then human factors. There's cultural elements. There are economic elements. Wherever the jobs are, there might be more people there, right? Because it's a pull factor, as we call it. The history of the area might lead more toward having particularly high density or low density. So, for example, the east coast of the United States historically was settled first by European settlers, so they've historically had a longer time to build up populations in some cases in smaller areas than others. Politics are always a factor as well. These are human factors compared to physical factors. So when you look at this map of Asia, in India and China, there are some very, very densely populated areas, and you have to start looking at why. And you can see the legend here. Okay, the beige areas are low density. The dark red areas are high density. Density meaning population, people per square kilometer. So the number of people per unit of area. And along China, you can see the coastal areas have a lot of people. India, the coastal areas have high density. Coastal areas, and Bangladesh here as well, are always going to have higher population densities than others, whether it's because of the economic opportunities in those areas, the trade that occurs, or historically because that's where those cities first started. You can also see on the second map here of Asia, the second why, the big why question. Why is density so low here? Well, now we're getting into physical factors. So this is the Himalayas. There's mountain ranges here. There's deserts in Central Asia. So of course, there isn't going to be a very high population density in those areas. And over here on the east coast of China, another reason for that is urban areas. These are where all the cities are in China. So of course, where the cities are, that's where the culture is going to be. That's where the political spheres of influence are. That's where the jobs are, economically speaking. So because of that, you're going to have higher population densities in those urban areas. Now, you look at population density around the Earth, it's not too hard to see that physical factors play a huge role. Up here in northern Canada and northern Russia, okay, it's very cold. The climate is not very suitable to human life in those areas. Down here in the western part of the United States, you've got mountains and deserts. In the central part of South Africa, you've got the Amazon rainforest. In northern Africa, you've got the Sahara Desert. Australia, you've got the Outback Desert. So because of those deserts, these are physical factors that are leading to a distribution of the population that is very low in these areas and very high in the areas that are physically more suitable for people. So, when we talk about population density, that's the number of people in a given area. But there are actually 3 ways to measure population density. The one that we usually are using is what's called arithmetic density. It's just numbers, okay? Some people pronounce it arithmetic density. You've probably heard that term arithmetic used before. So this is just the number of people per unit of all land. Okay, so just people per unit of land. So it has nothing to do with what we see down here, which is like farmers or farmable land. It's just people per unit of land. That's population density or arithmetic density. But the other two are physiological density and agricultural density. Physiological is the number of people per unit of arable land. Arable land means farmable. It's fertile land. It can be farmed. Well, if you have a very high physiological density, that means that you have a lot of people, but not a lot of farmland. And that's concerning because you need farmland to provide for your people. You need to feed your population. So a high physiological density is not necessarily a good sign. You do tend to see it in very large urban metropolitan areas. That's kind of less concerning because obviously there's a lot of money flowing through those areas and a lot of resources. So it might not be as concerning in a place like New York versus some other parts of the world. However, agricultural density is pure farmers and farmland. It's the number of farmers per unit of farmland. And so that means you have a lot of people, if you have a high agricultural density, a ton of farmers, and not a lot of farmable land. Typically, that suggests that there's a lot of sustenance farming happening, meaning people are farming their backyard for food, basically. That's what they live off of. That's what sustains them and their family is their own farmland. So using different methods of population density can reveal different things about the population. You know, it can tell us what kind of pressure is being exerted on that land. And so here's population density. This is just basic arithmetic density around the world. You can see it's a little bit higher in Europe. We can see some high spots around the United States, on the East Coast, on the West Coast, here and here. You can see India is very highly densely populated. Eastern China, very densely populated. Japan, same thing. Okay, some parts of Southeast Asia here. So when we go to physiological density, it tells a different story. Okay, but it's also showing you this in terms of a choropleth map as opposed to isoline. So it's able to present the information in a different way. But you can see that high physiological density here, the orange, occurs in a few areas that I want to point out. One is here, okay, in the Middle East. The Middle East is going to have very high physiological density because there might be a lot of farmers, but there's not a lot of awesome farmland. There's a lot of sand here, right? So there might not be a ton of great farmland, which would lead to a high physiological density. Out here in Japan, there are a ton of people, but not a lot of farmland. Okay, and I think I misspoke down here. There are a lot of people in these areas, not farmers. There are a lot of people in these areas, but not a lot of farmland. There are a lot of people here in Japan, but not a lot of farmland. Same thing out in these archipelagos, these island nations down here, right? There's a lot of people, but not necessarily a ton of farmland. Bangladesh, right here, this little one. Millions and millions and millions and millions of people, but a very small country, so not a ton of farmland. Finally, agricultural density. Okay, agricultural density, remember, is the number of farmers per unit of arable land. So, agricultural density is very, very high, typically in what we would call underdeveloped or developing areas. Areas that aren't very industrialized, meaning there are a lot of farmers in those places. That's nothing against farming, it's just that if you don't have other jobs you can do, what you might do is just farm your section of land to feed your family, and then if you have any extras, you can sell it in the marketplace. Well, if there are tons and tons of farmers, but not a lot of farmable land, you're going to have a very high agricultural density, meaning these dark green countries. So the countries that we see, Central Africa, Eastern Africa, West Africa, South Asia, Southeast Asia, parts of Central America here, we know that those are some less developed areas of the world. And so, unfortunately, there is this common link between agricultural density, high agricultural density, and a lack of development in that area. Doesn't always mean that, but a lot of the times it does. When you look at arithmetic density throughout the United States, there are some key trends to notice. So the dark red areas are the most dense. You can see San Diego and LA down here, high density. San Francisco, Seattle, here's Chicago. Out here you've got New York and Boston and Philadelphia. Down here we've got a bunch of cities in Florida. So the point is, urban areas, cities, are typically representative of high population density, which makes sense. There's a lot of economic opportunity within a very small area. And then, of course, the eastern half of the country you can see is way more densely populated than the western half. Some reasons for that, mostly physical. Okay, there's mountains over here in the west, and there are deserts here in the west. So it's not very suitable to the human population. Additionally, a lot of these states like North Dakota, South Dakota, Nebraska, Kansas, very big farm states. So you've got these large plots of farmland with not a lot of people actually living there. Here's a dot distribution map of the same thing. So what are the consequences here? Well, they could be quite drastic. It really depends, and it depends on a few things. One, what's the physical size of the country? In the United States, we have one of the largest populations in the world, but we got a big country physically, so we can actually support a huge population. Some areas, not the case. You got a lot of people in a small area. The economic power of the area. Here in the United States, we've got a big economy, a very powerful economy that can sustain quite a few people, so it's not a big deal. In other areas of the world, they've got a giant population, but maybe not the economic power to provide for all those people. So there are many different reasons that the population might impact a country more or less. Either way, here are some of the things that can happen. Economically speaking, the more people you have, if you don't create jobs for all those people moving into an area, you're going to have more unemployment. You might have increased poverty rates. You might have increased homelessness, increased hunger, all the things that go with that. And we can't have that. So socially, we have to take care of it. So all of these people who maybe can't provide for themselves have to lean on the government a little bit. And that's okay. We have to do that sometimes. But if too many people are leaning on the government, that's going to put a strain on those social services, things like education, healthcare, any of it. Okay, and then environmentally speaking, the more density you have among your population within a very small area, we can see this in some places in China, you can see it in even some places in the United States. If you have too many humans within one area, too much human activity will create waste. And in those areas, the environment is going to take a toll for it. There could be air pollution, water pollution, land pollution, any of it. But too much density in one area is going to place too much strain on those resources. So any given country has what we call a carrying capacity. There's only so many people that a particular area can carry, meaning the resources and the environment in an area, in a country, whatever, can only support X number of people. And once we go beyond that, as you can see in the cartoon here, okay, those resources are going to be way down, and the whole population could end up suffering. Two more consequences. Very last thing for this video lecture. Two other consequences of population are dependency rates. One is called high youth dependency. One is called high elder dependency. The youth dependency means, if there's a high youth dependency, it means that the population of people under the age of 15 is really, really a large percentage of the entire country's population. So there's a huge bulk of young people that need to be provided for. On the other hand, a high elder dependency would suggest the opposite. There's a large number of people over the age of 64 that the country has to support. They're not just going to let them die, but these people are going to run into medical issues. Additionally, they might not be able to work at a certain point, just physically, right? And so if they can't contribute to the economy, somebody has to take their place. But what a high elder dependency says is that there are more people over the age of 64 than are replacing them at younger ages. So if no one replaces those elderly folk, then the economy could end up collapsing. So both of these situations place a burden on populations. However, they're dangerous in different ways. Whereas the high youth dependency, you might have schools that are packed to the brim. You're going to have a lot of young people that the government is going to have to potentially provide for if they can't provide for themselves. The high elder dependency, if you don't have enough people coming into the economy to replace all of the elderly who are retiring after their years of work, then that economy is going to collapse, and that could end up hurting everybody. So they're both dangerous situations to be in. The idea is that a population wants to find the right balance between the two. So that's it for today. If you want to take a look at this video, this is showing you a population pyramid over the last like 50 years plus some. They predict the future. And these population pyramids are what we're going to be working with in your next couple sections. So that's it for today. Hope this all made sense. If you have any questions, feel free to email them to me, or in one of our Zooms, we can always go over these things as well. All right, thanks everyone. See you next time.